Hi all, I am Bhavna. Today I am here to discuss about one of my project named Qwerty-based-spell-corrector. Coming to the project. Actually, in an information retrieval system, spell checking and correction is done to retrieve the relevant documents. Okay, the aim of the project is to implement the spell checking software, and the main focus is on the fat finger error. Then comes what is fat finger. Uh, the fat finger error can be described as an app user or the keyboard user. We are more likely to misspell by clicking the adjacent letters instead of the intended one, which is termed as a fat finger error. And this algorithm can be done using edit distance concept. Edit distance is a Now, what is edit distance? Edit distance is a minimum number of operations needed to transform one string to the other. Okay, edit distance can be performed by many algorithms like Levenstein's distance, Hamming distance, longest common subsequence, etc. And the most popular technique is a Levenstein distance, which allows insertion, deletion, and substitution, all the three. Now, Levenstein is actually used to measure the distance between the two sequences, like it is a minimum number of single character edits required to change one word to the other. And in the Levenstein's distance, it does not take into consideration about the distance between the letters on the keyboard. Therefore, came up with a new solution named Qwerty-based spell corrector, which takes into consideration of the distance between the letters in a Qwerty-based keyboard. And this can be shown here. Like, I have taken a file which is consisting of 200 country names, and this is a QWERTY main in which I have invoked QWERTY edit distance which I wrote, and the Levenstein algorithm which is already present. And if I run it, like it asks us to enter the string, and if I enter like in the and enter, it gives like India. Like it shows, it checks into the file which consisting of all the countries, and it retrieves the one which is closest to it. uh, and now the difference between the Levenstein and Qwerty is now shown properly. Like if I give, instead of D, if I give a letter which is adjacent to D like S and IA and hit enter, it shows you like the closest element cost using Qwerty is 0.96, and using Levenstein is 0.8. If I again run it with some, like instead of S which is adjacent to D, if I give a random element like L and IA, it shows you like 0.92 in Qwerty and 0.8 in Levenstein, which means like in Levenstein it is a constant, like 0.8 is a constant if you give S or L something. But in the Qwerty it is different, like it was now 0.92. This is basically done by taking all the elements cost to an particular key in the keyboard. Like if for the adjacent one we have given cost as 1, for the diagonal one we have given 3, for the up element we have given 5. So this is making us to get the different cost, and this is used to get the most relevant outputs than Levenstein. So this is effective than Levenstein. And thank you. If you have any doubts, contact me.